Hello students, and welcome to this video where our goal today is to discuss something called higher order derivatives. So by now it's my expectation that you feel comfortable finding derivatives. We have used the product rule, quotient rule, chain rule by this point. And so now you're thinking beyond looking at just the first derivative. So we know that if we have a function and we want to locate its derivative, there's two ways we can notate it, as you see I've written on your screen. But what I want you to see is that there is actually a way to take the derivative of a function whose derivative you've already taken, and that would be your second higher order derivative. In fact, let's say I wanted to take the derivative of that, I call it double derivative function. That would give me a triple derivative function or a third higher order derivative. So there's several different ways to notate. You notice I've given you some notations here. Maybe I want to notate my third order derivative in several different ways. Some other things I could do is use the third power on my d, and that kind of shows me that I'm taking the third derivative. I could represent it like this, which shows me that I'm trying to take the third higher order derivative of my f function. I could even notate it like this, which we don't see very often, but you could run across that in a textbook. Okay, so just wanted you to see that you can take higher order derivatives. So let's do an example just to make sure that this is clear. So let's say that we have a function and it is represented by 2x to the fourth power minus 3x to the third plus x squared minus 5. I can take its first derivative using the power rule. That gets me 8x cubed minus 9x squared plus 2x. I could take the second derivative, again using the power rule, would give me 24x squared minus 18x plus 2. And I could even take the third derivative, again using the power rule, would get me 48x minus 18. If I wanted to keep going, I could do a fourth derivative. That would get me just 48. And it's not until I get to that fifth one that I end up with the value 0. And then keep in mind, I could evaluate. So I could say, you know what, I want you to go find the third derivative at the point 2. So I would be using my third derivative function. And for every x I see, I would be plugging in 2 and then solving. And that gets me 96 minus 18, which is equal to 78. Okay, so really easy to think through higher order derivatives. Just wanted you to have a quick video to show you that. Along with higher order derivative comes our real world application problems. So if we start with S, we represent that by f of t. We have already looked at this before, and we've stated that that represents our position function. And I want to make sure that you feel comfortable with this idea that if you want to find the derivative of s prime, which is the same thing as saying ds over dt, then what you're doing is finding the derivative of that function, f prime of t, and that represents your velocity function. And then if you want to find s double prime, which is equal to the d squared s over dt squared, that's finding the second derivative of your f function in respect to t. That is going to represent acceleration. So as you go to do real world applications and you're being asked to identify position, velocity, and acceleration, you know that they all come from each other in that order. Positions, the original, velocity is your first derivative, acceleration is your second derivative. Hope you found this video helpful. Of course, if you need anything further, please don't hesitate to reach out, and have a wonderful day.